Okay, so let me start streaming the screen. You, Tom, please. Or Tom, you have to turn sound off on YouTube.
Sorry for that. I fixed it.
Okay, and I think I have to do this. And now, more or less, although you won't be able to see me via Discord, but you can see me if you want via YouTube, but you'll have to turn off the sound via YouTube. Okay, so what is it? Sorry, I think I'll close this. And I'll go here and here, and I've rearranged the topics a bit. So I think I can start, right? Maybe anyone has any questions? Feel free to unmute. The only thing that this is being recorded. Regarding everything else, I think you're free to unmute when you like and ask any questions. And I really hope that this kind of communication will like make the streams more interesting, more fun. Okay. Can anybody speak a bit so I like just say something just to test that everything is working okay?
Hello, Alexander. How are you doing today?
I'm doing good. I'm doing good. The streams are after the work, so I'm a bit tired, but overall I'm nice. Okay, so then let me start. I've picked 3 topics that are pretty heavy, and I think that like answering these topics in text chat will be really hard. So I just wanted to talk about these topics, and I'm going from the most, at least for me, most like obvious stuff, where technically everything is quite obvious and I can explain it, and there's no risk that we get stuck and sit for too long, and then on to the technically more hard topics for me again. So let's start with FK, IK, and vector interpolation. And okay, so let me just this is an early access version, so I'll encounter the same bugs you will encounter. Okay, so IK and FK. I think that probably most of you know what IK and FK means, so I'll go here more into the technical details of how they are different and what problems it can cause. So, okay. So obviously, if you have IK turned on, each the points there, for example, this point, let me turn on linear interpolation, then we can see that the position of this point, the hand point, the main hand point, it is interpolated linear from this position to this position, and it just moves directly. And if I turn FK, then the global position. Okay, I'm setting here flags so I can see always so I can select now different frames. I'll always see the trajectory. So if I turn on FK, then you can see that this is not a linear interpolation anymore. In fact, it interpolates using its FK coordinates for each of the points. So it interpolates differently. So what does that mean for us? Well, obviously it means different interpolation, but I just wanted to go into some details today. What interpolation is used and where? And I'd say that there are in our standard point controller rig, there are different types of data. You can actually see them if you select a point here in the point local controller. You can see the data that it has. For example, this one has position and local position, and they are the same. They're like basically the same positions. Now, if I go up the hierarchy, I will see here direction and position, and already I can see that there are these two data. They're different. Direction is just has a value of 10 by the z-axis. Okay, and that is because this is the standard axis that points to the next point, and obviously it has some global position. And then if I go up even more, I will see that this one doesn't even have global position here. It has pitch, roll, and IK direction. And it actually has a position. The position is usually used to edit on frame to actually see the point, etc. But this point already has 3 data. So yeah, so it has 3 types of data. As local data, it has pitch, roll, and length. I'll cover it very briefly, but it's not. I think right now we'll more look at the types of data than what actual data is situated here, and we'll look at this direction data especially. And then we have IK direction, and it's different. Well, it basically contains this IK direction is basically a vector that stands from the parent point, that starts on the parent point and ends on the child point, on the current point we're looking at. So this is a global vector, and this is the IK data that actually gets interpolated. It's not like that for all the points. For a lot of them, it's like that. For this, what we call directional points that control the main direction of this bone, and it is like that for the additional points. Although additional points, they don't have. Here we had. Okay, let me do it like this, so it doesn't jump. We have pitch and roll, and for this we only have twist. And then for but for some points, for example this point, we have a global position. So if this point is set to IK, the data that gets interpolated is this global position data. And if it is but for many of the other points, like this ones, IK direction gets interpolated. And the logic here for IK direction to be interpolated is that okay, let me remove all the FK and just show that if global data was the data that gets interpolated and that is actually stored in the frames, then if I would, for example, decide to copy this key, okay, let me copy not the whole character but only the head. So I press Shift and middle mouse button, drag with middle mouse button, and right now it doesn't change anything. Okay, let me change the rotation somehow. Suppose it's like this. And now if I copy data from here and copy it to here, my character head will just bend in this direction. It will have, basically it will have the same global rotation. By the way, it's global rotation because let me just show that. If I rotate the whole character, and now I have different rotation here, and if I copy the rotation, it's still the same global rotation. So it's not local rotation of the head, it's the global rotation of the head. If I had this, if I set FK to this key and copy it, then it will be the local rotation. You can see the difference. Let me, to make it more obvious, just paste it in a neighboring frame. You can see that it is pretty different. Okay. So okay. So this is this direction data that is actually held on the keys. It's stored in the keys. It gets interpolated. So this data actually defines the behavior during interpolation, during moving keys around. When we move keys around. So that's the main idea of this data. And okay, I just want to ask, maybe there are some questions, because what I really wanted in this in this new format is that maybe somebody will be asking questions, or maybe like everything is too unclear, and I don't know, maybe I should start from scratch, or
I have a question about FK keys.
yes, sure.
Okay, so from my understanding, limited understanding, the FK keys are, their only purpose is that if you were to copy the key further down the timeline, it would keep its local position, and that's the only thing that its purpose is. Are there any other purposes, like use cases for the FK keys, or do we just use the IK keys at all?
Well, yeah, there are potential purposes for the FK keys. Suppose you don't always have the same set of keys for all the tracks. So, for example, you can have this. You can have a key only for the head on this track, and have no keys for the body. Then, if you have an IK key here, you go to this frame, you rotate the whole character, I go back here, the head is still in the same, it has still the same rotation. And let me put this rotation back and put FK here. Okay, sorry. And now rotate the character. And okay, it's not that obvious that it got rotated. Maybe I have to... Let me make this example a bit more obvious. So now you can see that the head actually got rotated pretty much. Or, okay, let me remove the key. Put a key again, and I'll put this kind of head rotation. And well, yeah, it doesn't look nice, but I think it will be more obvious how it works now. And if it's IK, then I can rotate the character. For example, I can rotate it back. And now it still looks the same way. Okay, let me just leave the rotation of the head, so the rotation of the neck will not be present here. So now you can see that I can rotate the character pretty much. The head, it always looks to the front. And now let me set FK key here, and I go here and I rotate the whole character, and I go here, and you can see that the head didn't move. It kept its relative rotation from the neck. So what's kept here is the relative rotation of these 2 points from the parent. I don't know if I was able to explain it.
Yeah, it was great. Thank you very much.
So yeah, and by the way, here this pitch and roll are the and twist. They define the local coordinates. And this IK direction and projected, okay, we can't see it, but it's called, I think, projected additional direction. This is the IK data that is stored. And by the way, before the last version, we had a different way to store the data, IK data. Everything was stored with using the global position. And if we press here IK enabled, let me press it for the whole character. Now the global positions are stored, and like that basically that means that now if I move this, if I put a key here and move it, okay, something bad happened here with the character, but nevertheless, let me move it, then the actual global position will be copied. But in the current rig, the only thing where actual global positions are used instead of these vectors are it's the pelvis and any point that comes after the direction controller. So the basic points, the main points of the feet and the hands. They have as their IK data, they have the global position. All the other points, this, etc., all of them, as the IK, they use the directions. Okay.
And we have a question from YouTube about this in games asking, so FKK is local space and IKK is global, right?
FK is local, IK is global, but different points have different IK. So it's always in global space, but it can be okay. So if we go strictly, if we're talking like about strict, saying everything very strictly, then if it's okay, if it's vectors, then I would say that this IK direction, either you say it's a vector in global space, meaning that it's in global rotation space, but it is a vector that goes from this basic point to this to this direction point, or you can say that it is a position that is in always in the space where we have global rotation, but the position is defined by this point. I don't know how to do it. What is a more correct way to put it? But it's this vector, and this vector is placed in the global rotation space. So sorry, I don't have it more structured like a lecture, but yeah, maybe I'll do I'll structure it better someday. But I hope it's understandable. But if not, please ask, and yeah, maybe I'll understand how to explain better.
I think that in the games he just wrote, okay, no problem, I'll try to find out. But yeah, I suppose that you can ask additional question to Alexander, and he will try to explain more about this. Or it will be a topic for extensive stream.
Okay, let me go here. I think that this the origin of this question was this scene. And there was a problem. Okay, I'm really sorry. As this was for me the easiest question. I think why my arm pull vector trajectory is doing this hitch. There is no key here. It only happens with FK. Okay, so let me now explain why this hitch happens. Maybe I was too naive. and I didn't test it out enough. I think that if I won't be able to answer this question right away, then we'll have to move it to the next time, because yeah, I'm afraid I somehow skipped this and I didn't look through it, and this hitch is not that obvious as I was thinking. But before we get we try to understand this, let me show a couple more scenes that I've prepared. So I just wanted to show that what we use for I was telling you about this IK data that is sometimes position, like for this hand, and sometimes this IK data is a direction, and for directions we use a special type of interpolation, and it's also the pole vectors, what we call in Sascadeur direction controllers. They also, as an IK data, they use a global direction vector, and we interpolate global direction vectors, what we call with an interpolation on a sphere. So let me just set up some points, and you can see that here I have this direction object, and you can see its trajectory, and okay, let me put here are my keys. The radius is always the same. Let me remove the manipulator so it doesn't disturb you. For convenience reasons, I put the pivot for this object to the center, and so you can see now these are the positions. And if I show the whole trajectory, then you can see that it always stays on the sphere. So it's always interpolated on the sphere. Even if I turn on linear interpolation, then you can see that it interpolates with something close to a slurp interpolation, although it's different, but slurp will look a bit slurp will look alike, but you can see that it's still always the position of the point always stays on the sphere. And if we're interpolating positions, then it moves away from the sphere. And if, for example, I put linear interpolation, then it will just go in straight lines from one point to the other. And I think for pole vectors and directions, it's way better when they interpolate like this. But there's one problem with this pole vectors interpolation, and the problem is that if I put clamp Bezier and if I copy this key, then for global position, clamp Bezier can hold like it understands that here the positions are the same, and so it doesn't it just holds its position throughout this interval. And the same thing will work if it's if it has like constant. So I would basically say that clamp Bezier works with positions, but it doesn't work for now with directions. We want to improve that, but for now it doesn't work. So it's basically the same standard Bezier and clump Bezier, and that can sometimes be a problem if you're working with direction controllers. And so what you can do in direction controller is that you can go here and say fix position, and then it will work with a fixed position, and it will, if I put IK here, but I know this is not the question, but just wanted to make it clear that right now it will just hold its position, and so you will be able to use clamped Bezier for it. But let's put everything back and get back to the question about this scene. Yeah, I'm sorry, I think somebody wanted to ask something. Nope.
Artem wanted something to say. He was trying.
No, I already forgot what I was asking. Or we talk about FK. I think FK it's good only for interpolation, for arcs, to make arcs more how would say, to make arcs more like beautiful if you wanna make fast animation. But in the end, you anyway need to make it IK. Of course, not every part of body, but FK usually work better, so you can move your keys, your frames. So I see it like that. But in the end, you should go to IK too. But of course, not everything. I hope it was clear.
Okay, yeah. Okay, so there's a problem with this hitch in the interpolation. I think I will have to skip it because unfortunately I kind of sorry, I kind of prepared everything around, but I didn't get to the scene, and right here it's definitely just some kind of bug. But what I want to say here is that when we are using FK interpolation, this direction controller actually doesn't work at all. So it is basically deactivated. It is just updated by the data coming from this point controllers. What's strange about this scene is that the data in the point controllers, it's like it's very steady. There are no I don't see any problems with this data, but we can see a hitch here, and that is strange. And yeah, that can there are a number of things that can potentially go wrong with this. One of them, let me just check, and if I'm not correct, then we'll move further.
By the way, we have this error few days ago, me and other guy. So when PV in FK mod, when pole vector in FK mod, it going like this. Sometimes when your hand straight, he don't know what to do, and he like bump, make a little bump, but it's not scary or something. Hands still good. Hands still do good. Steady.
Mm-hmm.
If you turn on IK, I think it will.
Yeah,
it will calculate right.
Yeah, it will. The problem will go away. But so right now, because FK is turned on, it actually gets the direction and then the position. They get calculated Okay, let me just deactivate it. Then we'll see here how it gets the data of this pole vector. It gets calculated based on the points positions, and also based on this offset. And the only thing I can think right away is that maybe this offset is not very nice. Let me put it here so I can see it. And also let me please... Oh, sorry, I have some external sound. Okay, I think I should be able to see it in the graph editor now. Well, it also interpolates quite well. Hard to say what goes wrong right here. So yeah, I'll have to look. We'll have to get back to this topic next time. But at least I hope that all the other stuff I explained was understandable. So how this interpolation works, how it is kind of different. Yeah. And if we put ik here, then the pole vector itself, its data will get interpolated, and because of that, the data that is actually interpolated right now, be it ik vector, global position, or something else, the data that is actually interpolated, it will always be good. Usually, it will always be smooth. The problem usually is with some other data that is not smooth when this data is like the main one. So okay, then let's get to the next topic. Kind of getting scared right now that we're off schedule, but okay. Spin and behavior in interpolation. So I remember we had the scene was this I think Felcher combo, but I'll try to show it on just a standard scene, just a bit easier for me, but I think it can be used for other objects, like for other scenes as well. So the question was that suppose I want a rotation. For example, I want this sword to rotate in the hand. So what can I do? I can put a key here, select the sword, rotate it. Suppose I want to rotate several times, but okay, let's start at least with one time. I rotate it, I put interpolation here, and you can see that it just goes via the shortest road and doesn't actually understand that I want to rotate the whole way around. And when you're working with a character, creating some fighting scenes animation, then this is not as vital. A lot of times you don't have the parts of your character rotating very fast, and unless you're doing like very speedy jumps, you don't make your character rotate very much as well. For example, if you're doing skating animations, then you would want your character to rotate a lot. So That's why it wasn't like a very high priority for a rig to be able to do that. And yeah, and it was made without thinking about cases like this. You can overcome it in some ways. For example, one way to do that it would be to place several keys and select them, turn on interpolated mode, turn linear interpolated mode, and then let me just interpolate. Okay, I won't put additional keys, and now I will rotate. Okay, well, one more thing I'll do is I'll put my trajectory here so I can see how this point moves, because this point doesn't move at all. So now I rotate, and you can actually see how the rotation is applied. I still can go only halfway, and then I have to go halfway again. Okay, and even third time, but it will be pretty good rotation. Okay, not as good because I put on linear interpolation, but okay, right now it's more or less good, although it's still not ideal. It's still not what I really want. That's more due to interpolation and how it gets calculated. If I had turned off interpolation, I think it will be better. Okay, let me automatically bake the keys. But the fact that you have to do it in like if this is something you need to do and then you can forget about it, that you can use this way. But if you wanna, suppose you wanna you want the sword to rotate as if it's like part of a helicopter. What if you wanted to make several circles? So if that is if this is what happens, then it's a big problem. And suppose you want to control it after that. So if that is how it is, then what I would recommend right now is to use constraints. So let's start with constraints. I'll need to create some object that will use as a constraint. I will go with a cube right now, but it's far from ideal, and I think that with time we will create better objects for things like this. Okay, then let me turn off interpolated mode, and let me copy paste this position to my mesh object. And now what I'll do is I'll constrain the sword to this cube. Rig additional and constraint points. And I will have in my selection the constraint points. And I can usually I put them on a separate layer, track. So put it here inside the sword. Now they also have the settings, and for cases like this it's easier to put the setting as to turn on the setting active on frame, so the constraints will be active on frame. And now if I put a key, suppose here, and I turn this constraints on, right now you have to turn them on with Shift R in keys and Alt R in intervals, and it is usually a fixation for the points, but for constraints it's basically a turn on, turn off. In the future you will be able to turn them on and off in the property editor. So this is kind of just a hack for now to while the system that will be used in future is not yet ready, so you can somehow turn them on and off. Okay, and now what changes now is that in this key I'm not able actually to move these points. So they say, okay, there are several functions that write into this point, and that is because the constraint is actually holding, it's dictating how the point should be placed. But if I rotate, okay, sorry, there's some bug. Okay, if I rotate this cube, then the sword will rotate with the cube. Okay, suppose I rotate it, I turn on the interpolation, it doesn't work yet because I have turned on. Now constraint is turned on, and you can see that the sword follows the cube. But the problem is I still can't make the cube rotate several times, and this is just a flaw of Sascadeur right now. It always applies global rotation, and it can't it doesn't know how to apply several rotations. This is the first problem. The second problem is that even if I turn on graph editor and here pick local rotation, this is the rotation that is actually interpolated for all the transforms, and I select it and I try to set, for example, I want to turn 600 degrees, it just jumps back. That's because we automatically for most of our rotations we automatically apply what is called Euler filter, because a lot of our rotations are set from global positions of the points, which are set from quaternions, and so we always apply this Euler filter automatically, so nothing gets messed up. But for this object, we want to actually control the Euler angles, as you control them in a lot of 3D software like Maya or Blender. So we'll have to go here. You can see that all this is very crutchy for now. Go here, rig additional, switch Euler filter for selected, and turn off Euler filter. And now via these curves I can control the rotation. I can set some high rotation, and you can see that you can basically make the sword rotate. Yeah, not very easy and convenient, and we do plan to make the constraint system better. We also plan to make this probably you will be able to create some special objects that you will constrain points to, and these objects will have this Euler filter switched off from the start. And also what we need to do is for manipulators to be able to when you rotate several times, to be able to actually change record this rotation. So yeah, you can see now it's all messed up because I messed up my rotations here. Okay, so that's it for the spinning motion. Maybe there are some questions.
Is there a way to consistently track the speed of rotation. So let's say that you're not using this interval edit mode to have the arcs go consistently on one speed.
You mean if I apply all this system with the constraints, etc., then how do I control the speed, right?
Yes.
Well, this okay, right now this mesh object is on this track with the head, so if I just turn it to linear, then the speed will change. It will rotate with the constant speed. But basically, if I set it to Bezier interpolation, I can control the speed by adjusting the, I'm not sure how to pronounce tangents. So this will adjust the speed. For example, maybe I want it to rotate fast at the start and then rotate slower and slower. Did I understand the question correctly, or?
No, it's all right. It's okay.
But if I didn't, then maybe it's okay. I think we can spend some time.
Okay, so in my I've sent you previously my sample scene with the Felcher combo, right?
Yes.
Yeah. So in that, I've had some problems with the the weapon, the glaive. Yes, the glaive. I've had it spinning in hand. And so what my problem was is that I've had a hard time tracking the speed at which the tip of the glaive rotates. So essentially there were bits during animation interval that it accelerates and deaccelerates. So it goes faster and slower. And so I was wondering if there is a way, or like maybe a tool or a script or whatever, to possibly track like what's the distance between the points. So let's say, okay, this point it travels at 10 centimeters per frame, and so okay, on this interval you have to travel consistently it's 10 centimeters, then you may accelerate or decelerate. Something like that.
Okay.
I was thinking about it too before, but I don't see it in any package or in any software. I think it's
if you on the first bit, if you see where there's a big arc, yeah, right here, yeah, this. Yeah, right here. You can. It is noticeable that in some parts the glaive it goes. Well, the rotation speed is not uniform. It is not like you could do in real life. In some parts it's normal, some parts it's slower, in some parts it's faster. So that's why I was having some questions about how do I make it better. Are there any techniques? Are there any tools or something that could make this animation better?
Okay, I see. Okay, so maybe here too okay, here I just maybe kind of misunderstood. I think that with constraints you could do that, although it will affect, if you use constraints, it will affect a lot how you have to work with this glaive. You have to always move it via this control object that you constrain your glaive to. but it can work better if you do that. One more thing you could possibly do. Okay, but you wanted to follow the hands, right? So
Yes, correct.
if I put IK here, then it won't be as good. Won't be as good. Maybe what you could do is, what if I turn on IK, then I think the speed will be kind of better, right? I don't know if it's...
I think there is no change, honestly.
Not enough. Okay. One more.
Well, there is a change, but it's minimal.
Yeah. So where is it behaving bad? I don't think we will.
I mean, it's if you play it normally, like press play, and I think it's possible to see with the naked eye that some parts there are noticeable bumps in speed of rotation of this glaive. If you can see, so that's it. I think it's at around frame 100, 110 actually. From 110 to 130, I think. There's a noticeable bump.
It's pretty strange. I can't see it on the trajectory very well, but maybe. So it should go very fast here, right? And go slower.
Yes. I mean, it goes very fast at, okay, from 12 o'clock to 3 o'clock. If you imagine that it's a clock. So it goes fast, but I wanted it to go slower, like to have it the speed of rotation to be uniformal. Okay, so it's a steady speed with no deaccelerations or accelerations. It's perfectly fine, perfect speed on the whole interval.
Okay, I do think this can be solved with constraints. It seems to be a heavy way to solve the task, but I think I'll experiment and I'll try to make a setup where it will work. It will mean that you will have to probably create some controllers that, like one controller that actually sets sets the plane in which we want the rotation to be, and then another controller that actually rotates inside this plane via its vector, via an angle, and then this angle can be controlled, and this angle will basically mean the speed of rotation. And then we'll also have to constrain our hands to the glaive so they follow the glaive. So yeah, theoretically I think it is possible to do a setup like this, but it's, what I don't like here is that the setup sounds very complicated. So if every time you want to do something like this you have to create a custom setup, then it's probably not a very good solution.
Okay, then another question: would it be possible to I've asked this question before. Would it be possible to track the distance between the points on the interpolated period interval?
You probably mean the distance between the points on the trajectory, right?
Yeah, right, correct.
Well, we can track it. I mean, but what do we do when we do track it? What do like?
I mean, so
Like color them or something, or
display numbers, I guess. Well, let's say that okay, this the first half has the point spinning at 12 centimeters per keyframe or something. The latter part has them spinning at 15 per keyframe or something. Okay, so the latter part is going a bit faster. Let's fix that. Something like that.
okay. So the goal is to basically track. It's basically to track them, right?
Yep, correct.
So the animator can understand and fix it with his own hands.
Yep.
Okay, I think like putting numbers here that show like the length of the interval is like this is a task that we could do. It's not very hard. I think probably not very easy because you have to positionate them nicely on the screen, and that sounds like a pretty complicated
I think
algorithm.
if you put numbers on these arcs, it will be mess. But if like Zdeck said, like colors or something, we for example we take A, we take starting point A, and we take end point B, and Cascadeur try to calculate the distance between arcs. So if distance small, medium, or B. So different colors. It's like RGB, for example, red, green, blue. So if distance small, part of small arcs will be red, part of medium will be green, or something like this. I don't know. I don't see things like this. It's probably
Yeah, but for example, for this edges, if I pull them, they become red. If I bring them closer, they become blue.
in arcs the same. So Cascadeur just he need to know that the maximum distance between the point of arcs and minimum distance, and he calculates. So minimum distance he make one color, and medium distance this color, and like something like RGB.
Okay, well, to put the reference point, do you know how the motion trails in Maya work? Like
Maya, in Maya, it's absolute disgusting.
no. It's not saying. I'm saying that when you turn on motion trail, each point in the motion trail is numbered. So say this point is 1, the first keyframe, the second, third, and so on. So I'm talking like this. So there would be the distance between the keyframes would be put in between those keyframes in the viewport itself.
You mean like it's a table where we have 1, 2, 3, 4, 5 and the distances, or
No, so look the points on the arc, and the numbers would be between the points. The numbers,
Okay,
I mean
okay.
the distance, between.
You just mean that it won't be such a mess if we put some points, if we put some numbers here. I don't know, 12.
Yeah, correct. Yes, correct.
14.
I personally imagine it like this.
Okay. Okay, I think we can like the idea is clear. The idea is clear. We can maybe experiment once we get our hands to it. I'll be honest, it won't be probably in like the next 3 months. But once we do it, but we do sometimes go and like make some tool better and rework it. And once we go and rework this tool, I think that these two ideas that we can show the length of the intervals via numbers or via colors of the segments both ideas are good, so we'll think about them and discuss them internally. So
Okay, thank you.
I don't know
If we have time, I have some more questions, but if the time pressures you, let's go to another question.
okay, let's have the questions because I think when I answer the questions, that's definitely some profit. And when I don't answer the questions, just tell my stuff, then I don't think everybody understands it. I think it's not structured good enough. So yeah, I think questions are in priority. So yeah, please ask the question.
Okay, you mean my question? I meant the questions that you wrote, the themes to talk about.
Yeah. I mean your questions. Questions from you guys are the priority than the themes.
Okay, so we have time. Okay. Another question I wanted to ask is maybe you've answered it before, but I'll ask it again. So if you put a keyframe, so let's say you pick any spot on the timeline right here in this scene, and put a keyframe there, watch how to say it. The animation tracks. Could you please make them smaller? Make them unroll them, something like that. To put the keyframe on all of the like this. Okay. So if you put a keyframe and see on the arc, on the trajectory arc, you will notice that the trajectory will change.
Yeah, I could do it with a much simpler scene. Okay, let me just add a cube. Okay, so it almost doesn't change, but that's because this curve is very easy to optimize. But suppose I set another type of interpolation. Then whenever I put a key,
Yes, this is my question. What's happening here?
Well, like the I don't know if you've okay. So first thing I kind of first impulse to answer is that if you've used any other 3D software, this always happens whenever you put a key. The curve changes.
Okay. So fortunately, I haven't used any other software than Sascadeur.
Yeah, because if you put another key, how it works? You have the interpolation curves. Let me open in Graph Editor again to just show it. You have this interpolation curves, and they're calculated, and they have there's some bug here, but let's never mind the bug. But we have this velocities calculated, or tangents. We have them calculated. They're calculated one or the other way, and whenever you put another key, now they get calculated in, for example, in this key 22. If I put this, a key to the 30, right now they're calculated based on frame 0 and frame 44 in frame 22. But if I put a key on frame 33, now they get calculated based on the values we have in the frame 33. So if you have some algorithm how to calculate this velocities, then probably your algorithm, if you add more keys, the values will change and the curve shape will change. So that's just how it works. And our default Bezier interpolation, basically it optimizes the values in such a way that whenever you put so it is so it's yeah, the algorithm is made in such a way that it almost doesn't change whenever you put new keys. If I put them here, they will change a bit. If we look very, very closely, they will change a bit, but the algorithm is intended for it to be as smooth as possible, and because it's smooth, when you place additional keys, the smoothness doesn't go away. So yeah, but suppose we have like, okay, in linear it wouldn't change too. Yes, in linear it wouldn't change. What if we have clamp, for example? It is already able to change once the clamp the difference of the clamp interpolation is that it has some limitations, and whenever we are close to these limitations will be affected, and the curve will change. So it's more or less a natural thing. Although with standard Bezier interpolation we try to minimize it as possible, as much as possible.
Okay, that answers my question. Thank you very much.
Okay, thank you. And let's move to the last topic, straight into hinge versus ortho to hinge, or it's just called Orthohinge. So we create a new scene, and I've prepared a scene where it's not so I don't have any rig here right now. Let me create a rig. Okay, I don't know why this is not working. And the question was about this leg, and by default you can see that it is the point is not placed in the same place as the joint. And the question there was actually that whenever there were several parts of it that it is not placed correctly. Now I for example select, I want the point to be at the start of the joint, so I copy the joint position, I paste it here. By the way, one of the problems is that this child objects move. This is not good, and this can be fixed, and we will fix it. But okay, let me fix it manually. And now I have this the positions of the joint and the positions of the points are the same, but if I press union to hinge, it will go like this, and this is obviously not the way I want my foot to fold. And so the question was basically, why does the direction controller vanish when I change the positions of these points? So why can't I create a direction controller with a hinge connection that is situated like this? And this is a limitation of Cascadeur, and but why we don't like why it wasn't a priority to change it is because at least for now I think that you actually should prefer this kind of connection over this kind of connection. Let me just generate the rig right now, and yeah, it doesn't have the direction controller, but let's just work without the direction controller. I just want to show some properties that suppose we do some math, etc., and we create a direction controller for this kind of scenarios. Although technically it's harder to do that, but if we even do that, I think that on the physical level, and like one of the limitations come from the fact that the position of these points actually defines the hinge connection between these two rigid bodies, this one and this one. And I think that you probably want this type of hinge connection, not this one. This hinge connection is pretty strange. For example, what can go wrong? Suppose I to work with a hinge connection like this one, I'll have to fix the points because there is no direction controller, and if I don't fix them, they will not work good. Okay, let me just show you what will happen. Okay, it doesn't work that bad, but okay, never mind. I'll fix them. And so you can see that, like, if I just let physics have its own way, the leg will bend this way. It doesn't actually. I can move it here, but it is still pretty strange. If I put what will be unachievable in this kind of setup, for example, if I put this point here, I can now change how my leg is bent, and I can always easily rotate the leg. But here, when this hinge connection is situated like this, if I try to move it up, it will bend here because it's not possible actually to keep this line straight. It's just like a physical limitation, the limitation of the physical bodies, rigid bodies, and yeah. So this is one of the problems that will appear because, or okay, if I sit down further, you can see that in this case you can always bend as much as you want, but in this case there are some limitations on how you can bend, and actually that affects when the character is not seated down completely. That affects the rotation of this joint too. So for now, at least in my opinion, it's better to have a correct connection, hinge connection here, and it will be okay that the joint is not in the same position as the point. What it will affect is that when you bend it and unbend it, the length of this joint will change a bit. That is true. So okay, it's can't. So this position can change very, very slightly, because the positions of the point and the joint are not the same, but it doesn't affect the joints too much. And again, as far as I know, in most 3D programs, that's how pole vectors work. They do change the local position of the joint, and I don't know, I think that's just the correct way. Otherwise, you have a very strange and I would say broken hinge connection, the physical connection between the rigid bodies. So that's why I think it's okay to use straighten to hinge in these scenarios. I don't know if the author of the question is here. Maybe there are some additional questions. Okay.
I have a question that's not about this topic. Can I ask it?
Yeah.
Well, actually, it's it's more of a request, I would say, not a question. Would that be okay?
Okay.
Okay, so it's about the linked scenes, the feature in the premium version of the Cascadeur, let's say. So when there are two scenes linked, and you accidentally double click on the meshes in the second linked scene, it will switch to another one. Would it be possible to have a setting for it to not be on? So let's say I turn this off, this setting, and it doesn't take me away to another scene.
Okay, let me just check. Maybe there is a setting like that, but if not, I will. Okay, so I double click and I
like
go
this.
here.
So let's say I have two scenes,
that-
one with a character and one with let's a scene of props. So like I don't know, an office, a jungle, or
Okay.
something like that. And if I okay.
So you turn this off, selectable, linked scene meshes, and now it doesn't.
Oh, it's that simple. Okay. Okay. My question is answered. Thank you very much.
Okay. Yeah, I hope it is in the early access, by the way, but I don't have just to see the way everything is structured in the free version. I didn't activate the pro version here, so. But if it's not working here, although I think yeah, it is. It should work here too. Yes. Okay. But at least it will work in the next version. Okay, maybe there are any other questions? If not, then thank you guys. You can see I'm
information.
yeah, I really feel like a beginner with the streams, and it actually helps a lot when I hear some voice feedback. I understand maybe at least part of what I said was understandable. So yeah, and I feel like I'm very, very deep into all these topics and Cascadeur. So a lot of stuff for me is quite obvious just because I worked. I developed Cascadeur for like I think 8 years already, and yeah, but I do understand that our documentation, our tutorials, they don't cover the technical information too much, so I'm very happy to provide it, but I have very limited time, and because of that I want to structure it in some way that like it's pretty optimal, and to be honest, for me as well. So and when you have some real questions for me, it helps very much to like understand what was covered, what wasn't covered. So yeah, thanks a lot. I hope we use this. We meet again in this same setup, and I think for the next stream I will get ready for the stuff I couldn't answer today. So yeah. Okay. Thank you, guys.
Yeah, thank you. Time to sleep.
Thank you.
Bye.
Good night.
Thank you. Bye.